Hello. Today I'm gonna teach you how to perform analysis of variance, or as known as an ANOVA test on a data set, on a given data set, to better select the variables or the features you want for to build a model. So today we are going to be building two linear models, and we are going to perform an analysis of variance on the models to see which one performs better. I'm going to be using R today. It's pretty easy. As you see, I have already written the script here. I'm going to be using the iris dataset. So first we need to load and attach to the dataset. And let's have a quick look at the iris dataset here. We have sepal length, sepal widths, petal lengths, petal widths, and the species here. Today I'm going to be predicting sepal lengths using the other features. In one of my model, I'm gonna use 3 of these features. In another one, I'm gonna draw petal widths. We will check it in a second here. Okay, so the first model, I'm gonna be predicting sepal lengths using sepal widths, petal lengths, and petal widths. Let's create the first model here, and let's have a review of the first model. Let's check the summary of the first model here, and here, as you see, we have a R squared of 0.85 and the residual standard error of 0.31 for the first model, which is good. And let's build the second model by dropping the petal widths, and let's have a look at the summary. In this model, we have 0.84, which is lower than the first model, and 0.333 for residual standard error. And now so as you see, for now we can say that the first model is performing better than the second model, but let's have an official and more professional test to confirm this. I'm going to be performing ANOVA here, ANOVA, the first model and the second model. And here we have the RRS, or residual standard error, for each model here, model number 1, model number 2 here. For the first model, which includes petal widths, we have 14 for RSS, and for the second model, which doesn't have that, we have 16 higher residual standard error. And here we have the F stat, and we have the p-value here. As you see, the p-value is pretty small, so it means that we are rejecting the null hypothesis. What is the null hypothesis? The null hypothesis says that or I better write H0, says that the models don't differ. But of course the models differ, because we have a pretty small p-value here. So this is how you perform ANOVA analysis on a data set to select the variables you want, by comparing the residual standard errors, and by checking the p-value. And of course, if the p-value was large, something around like between 1 to, or even anything greater than 1, we would fail to reject the null hypothesis. But here, as you see, we have a small p-value, so we reject the null hypothesis, which says that the models do not differ. But as you see, the models differ, so we get a better performance from the first model here. Thank you for watching my video. Please don't forget to share and like this video. Thank you.